Yeah, I started out at Northrop Grumman. Again, super lucky. Started there in a program for training engineers that allowed me to travel around the whole company 2 months at a time. I would get to go to one department, then the next department, and then after 2 years, I got to choose which department that I wanted to stay in, provided they had an opening. And lucky me, there was an opening in a composites R&D department. And so what that was developing new parts for either current aircraft or future aircraft. So I worked on B-2 bomber, F-18, Joint Strike Fighter, and then a few other projects that nobody's ever seen an airplane actually be made from. But we still made parts, we made them, we broke them, and tried to find new ways to make composite materials. One of my favorite projects was on the F-18, which was started as the C&D version, and the knock on the F-18 was it didn't have enough range. And by making it into a composite aircraft, we could make the aircraft over 1 meter longer, larger in diameter, yet still lighter. So now it could hold more fuel and actually be more maneuverable, but larger. So my responsibility on that plane was the vertical tails. The aluminum version had 47 spars and ribs to hold the structure together per vertical tail, and we were able to reduce that to 13. And because we made it so much larger, we complicated things by making each vertical tail into fuel tanks. So now we not only had to keep the structure together, we had to make it into a fuel tank. And those challenges, I mean, we learned things like you can't use silicon paddles to force down carbon fiber into angles, because the silicon would leach into it and make them weaker. We only would have found that out through testing. So to the chagrin of all the lab technicians, we took their paddles away and made them use other things that weren't as effective, but didn't leach material in. You know, and learning how to actually get material into a corner. We have a patent where we would put a little bit of extra material in a little bit away from the radius. So when the vacuum was pulled, you would actually pull material into that corner. So now you got a smooth radius. Usually you have, well, we see it all the time in our helmets. If we don't do a good job getting the material in the corner, it's resin rich. Resin richness is weak. So how to get material into the right place, and that's the key to working with carbon fibers, making sure you get it in the right place at the right time. Another project we worked on the F-18 was what was called the dorsal deck, which ran all the way from the very back all the way to the cockpit. And they swore that we couldn't hold tolerance on a piece 27 feet long out of carbon fiber. And so instead of trusting us, we spent $5 million of your tax money to prove that we could hold these tolerances. And so, you know, what we did was we used a bulk graphite master, then we used carbon fiber tools to make a carbon fiber part. So you had the same coefficient of thermal expansion all the way through. And sure enough, once we did it, we measured it and we showed that we could hold those tolerances. Then I went to St. Louis, where they put the front and the back together, and found out why they didn't really want to do this project, because they were afraid if they broke the tabs off the front, they ruined all 27 feet. So we found a workaround by making those removable, and it still worked out, and we saved a ton of weight on the whole thing. So anyway, those are some of the projects that I got to work on. We made a $12 million milling machine, 40 feet long. Yeah, it was pretty cool. 20 feet were these pneumatic pogo sticks that would come out of the ground and hold your part in place. And the other 20 feet was regular machine bed ways with a gantry system had two heads. One was a water jet that would come in when you wanted to water jet the edge, and some was the machining for holes and things like that. So, you know, again, that time being able to work in that kind of environment carries over to what we do here at Cali. Certainly we don't have unlimited timelines and unlimited budgets like we had then, but we don't sit on what we do. We're always looking what's next, what we can do better. I think when you think you've got it and you think you've got the best thing ever, people are going to pass you by, because you're always need to be looking for the next best thing.